Sectors and arc length. Remember these circle formulas. Area is pi r squared and circumference is 2 pi r. Find the area of a circle with a radius of 5. So area is pi times radius squared. And we usually write the constant first, so 5 squared is 25, and then times pi. You can leave it like that. The area of a circle with a circumference of 22 pi. Well, the overlapping feature between circumference and area is the radius. So we need to work backwards from the circumference formula to calculate the radius. So 22 pi is 2 pi r, replacing circumference with 22 pi. The pi's cancel, divide by 2, and r equals 11. So then to find the area of that, pi times 11 squared, which is 121 pi. Find the area of a semicircle with a radius of 13. So this is a whole circle. To get an area of a semicircle, we're just going to divide that by 2. So let's find the area of the whole thing, pi times 13 squared, which is 169. So then the semicircle is going to be 169 pi divided by 2. The perimeter of a semicircle with a radius of 6. Let's draw a small sketch here. We want the perimeter of this figure. So this part is going to be half the circumference. So if you look at the circumference formula, 2 pi r, if we want half of that divided by 2, just leaves us with a pi and an r. And then these two lengths, we want to include those in the perimeter. This is a radius and a radius. So we can write the perimeter of a semicircle as pi times r, plus 2 r's, 2 radiuses. And our radius this time is 6. So 6 pi plus 2 times 6, 12. The circumference of a circle with an area of 144 pi. Again, the connection between a circumference and an area is still a radius. So we're going to work backwards from the area formula to calculate a radius. So 144 pi is pi r squared. The pi's cancel, square root, so r equals 144, the square root of 144 is 12. So then to find the circumference, we just plug it into the circumference. 2 times pi times r, 2 times 12, so it's going to be 24 pi. Okay, today we're working with what's called sectors. Sectors are areas of only one piece of your circle. So we are going to be using the area formula, which is pi r squared, but we only want a chunk of that. Well, how do you know what chunk you want? The chunk that you want comes from the degree measure of your central angle, or it can come from your arc measure. So to find the area of a sector, we can write the formula down just over here if you want the area of a sector. The area of a sector is going to be the chunk of the circle, the measure of the circle out of 360 degrees. So it's going to be some degree measure out of 360 degrees, in this case it's 150 degrees of 360 degrees, times the area of that circle. So if you want the area of a sector, you're going to do some measure of 360 times pi r squared. So this problem says the area of this sector is 135 divided by 4 pi, and then the angle measure of DEF is 150 degrees. We'd like to find the circumference of the circle. So still, the same thing that overlaps between areas and circumferences is still a radius. So we're going to use this formula to work backwards. So they provided us the area of the sector, so I'm going to put that on the, on the left. So we're going to have 135 over 4 pi equals, I know the degree measure, 150 out of 360, times pi times radius squared, and the r is the piece that we're looking for. We'd like to know what that is. So if we cancel the pi's and we divide both sides by 150 divided by 360, you're going to get r squared equals 81. Square root of r is going to be 9. So our circumference is going to be 2 times pi times r, so 9 times 2 is 18 pi. All right, number 2, explain how you could find the area of the shaded region if you only knew the length of the chord and the measure of the arc. So we know that the length of this chord AB is 20, and then the arc AB is 100 degrees. And then the length of this is 20. So I'm going to help walk you through this. The way that you're going to find the area of the shaded region, let's kind of write a little formula. If we want the area of the shaded, let's think about how we could get there. If we just want that chunk, it makes sense that we would draw in these 2 lines here. Now those 2 lines there are 100 degrees of the 360 degrees of this circle. So now we're working with a sector. A sector is just one chunk of a circle. So if we want to calculate the shaded region inside of this sector, we're going to find the area of the whole sector, and we're going to subtract off this triangle. So then we can fill in the math that goes with that. The area of a sector is x over 360 times pi r squared minus the area of the triangle, which is base times height divided by 2. Let's take an inventory of what we want and what we have. So x, we do have that. We know that it's going to be 100 degrees. We don't have the radius, so right now we're going to be looking for a radius. We'd like to know how long is that radius r. I know what the base is. I know the base is 20 degrees on this, or 20, a length of 20 on this triangle, but I don't know the height. The height of that triangle, and then divided by 2. So the 2 things we're missing are our radius and our height from this formula right now. So if you take a look at this triangle, we've created for ourselves a right triangle. And on this right triangle, this measure of this total interior, or the central angle, is 100 degrees, which means that this angle on the top of the triangle is 50 degrees. And if that's the case, we can also figure out what the length of this, if this is a perpendicular, it's a perpendicular bisector, which means that that length is 10. So if I stand this triangle upright, which sometimes is very helpful, we've got our right angle here, our bottom length is 10, our vertical length is height, and our hypotenuse is the radius, and this top angle here is 50 degrees. So if we're trying to calculate this, we can use trigonometry to help us do that. We can use trig to help us work backwards. Now you can work with the 50 degrees if you want to, or you can calculate the third angle here, and the reason I recommend it is it'll make your trig a little easier. It'll make the answers to the trig be multiplication answers instead of division answers, but I'm going to go ahead with the 50 since the 50 is related to the 100. So if we want r, we've got an opposite and a hypotenuse, so that's going to be a sine of 50 equals 10 over r. So r is going to be 10 divided by the sine of 50. We also want h. So h is an adjacent and an opposite with the 10. So it's going to be a tangent. So the tangent of 50 is 10 over h. So h is going to be 10 divided by the tangent of 50. And now that you have those 2 things, you can go and plug them back in for r and h. So we've got pi times r, which is 10 over the sine of 50 squared, minus the base, which we already said was 20, times the height, which we just calculated, 10 divided by the tangent of 50, divided by 2. Now what I recommend is to plug this into this is an exact answer. It doesn't really get more beautiful than this, but this is a context problem, so it does make sense that we can find the area of this as a decimal. So I recommend plugging it in one piece at a time, so doing this term. So if you do this term by itself, you would get 148.66. And then if you do this term by itself, it's going to be an 83.9. And then when you subtract those, the area of the shaded region is going to be approximately 64.8. All right, let's try a farming example. An irrigation system uses a moving arm that is 1,200 feet long. So this picture is kind of hard to show, but we have these rotating irrigation systems, and they are on rollers, and they roll in a circular direction to water whatever you're farming. The end of the arm must trace an arc, so like it must trace an arc around the circle that's 6,300 feet long. And this arm is going to be 1,200 feet long. Through what angle should the arm rotate? So similar to a sector is the area of a chunk of a circle, but this is only the length of it. So it's only a chunk of the circumference. So if you would like to find an arc length, if you want an arc length, you're going to do some degree measure out of 360 degrees. And instead of multiplying by the area to find the area of the sector, you're going to multiply by the circumference because it's a chunk of the circumference. So times 2 pi r. So we're going to be working backwards because it wants to know the angle measure, and they gave us the arc length. So we're going to have 6,300 as the arc length, some degree measure out of 360, times 2 times pi times our radius, which is 1,200. So first thing we can do is divide both sides by the 2 pi times 1,200. So that cancels there. And then you would multiply by 360 degrees to undo the division. So then you would have x degrees is approximately 308 degrees after you type it into your calculator. Okay, the last two problems are review, so kind of checking your understanding here of the last two sections. So this one's a review from the last section, and this one is a review from today. So take a moment and try both of these examples on your own. Thank you.